So what I was going to talk about is how connectivity can reduce costs and increase speed up or increase the speed to time to market for data centers. And the objectives, which I could summarize, is, of course, for the data center operators, there are a lot of things in mind, but there are some very important ones. One of them is, for example, how to get online faster. This is one of the most important, of course, taking into consideration how much data is needed today at the world and tomorrow how much it will be needed. So time is money at the end of the day. So we would like to help, of course, from our side to get online faster for data centers. The second interesting topic is how to maximize the IT space. So if you have a data center, of course, you can have it, and optimally, you can also increase the space in the data centers, but you want to use that space very, very cleverly. And you don't want, for example, a power infrastructure in the data center to limit you. So we would like to help our customers and our operators to maximize the space and actually reduce the component size and be energy efficient. So this leads, of course, it also nicely connects, I wanted to say, to the previous presentation. Be greener, this is what we heard about. And at the other hand, to reduce the operational expenses. And then I will show you how we can do that through connectors. So the first topic is be energy efficient, and the pressure is there, of course, we just saw, and also it is coming from one side, from being more green. But what is the reason to be for this, especially for data centers, is that today, according to data centers globally use 3% of electricity of the world. So this is more than most of the countries themselves uses electricity. And the other hand, the CO2, the global carbon emissions, is around 2% from the data centers, which is actually about the same as you can also read here as the airline industry. I would say it's quite shocking if you haven't heard about it, because we can hear a lot about the airline industry, of course, and we are also encouraged to use other ways of transport, for example, to reduce our own carbon footprint. But it's a big thing. But as you can see, data centers are also contributing a lot to this, which is again interesting. Is how, for example, the CO2 footprint or the CO2 emission is coming together in a data center. This image is coming from Microsoft, and they show what kind of scopes we have. I don't want to go very much in details into these scopes, but I wanted to say is that we have direct scopes or direct operations and indirect operations when we run a data center. And actually 80% of the carbon emission is coming from the indirect. So means a lot of different things, but you can also see on the screen: manufacturing devices, transporting things to the data center, get the raw materials, and also at the other hand of the value chain, when we want to get away from our old equipment and then we want to scrap them or we want to dispose them, that is again heavily contributing to the carbon emissions. So where our company as an OEM, as a supplier for data centers, of course, we are playing into this 80%. So that's why for us it's very important also in our company to reduce the carbon footprint of our products before we get them shipped to any kind of infrastructure. And it just let me reflect short again to the previous presentation from Jay. So Germany is one of the So our company is from Germany. It's a global company, but is one of who started to get companies on board with renewable energies to be used, and this is where our company is also taking, of course, a lot of interest and consideration. But moving forward, still getting to the way how we are approaching the whole thing. It's just a little bit of a summary on the left side to see, okay, how the hyperscale data centers, so the big ones, the real big ones, are growing, and we know from the previous years that they are growing rapidly. We are talking a lot about COVID and the world after COVID. We are using a lot more digital services, even for fun at home. But at the end of the day, also for work, of course, we are having an online seminar at the moment. This uses data as well. So they are moving forward rapidly. And at the other hand, from the right side, what you can see, I mentioned today, it's 3% of the world electricity which data centers use. What will going to happen, for example, in 2030? There are no exact numbers on this graph, but you can see this is the green area, and from the best case to the expected case, it's going to be even much more than today. So our usage in the data center will be more. That's definitely sure. It's going to grow. And then when we approach from the operator side or any kind of company side, of course, we have different kind of cost categories, and then we have costs which we have to maintain in the company. One of the categories is the CAPEX, so the capital expenditures, and the other one is the OPEX. CAPEX is about, as it's in the name, capital. So it's about longer term investments. It's about, for example, bringing up the whole infrastructure for a data center. And just a short, explanation to the OPEX, that it's more about, so it's actually about the operational expenses, where, for example, buying power is also falling in. So this is, I think it's interesting to see, just to recap for many of us, but we have these kind of costs. The interesting thing starts when we look at the operational expenditure in the data centers, and this is on the left. You can see that electricity cost is well more than 50%. So when we want to go into a greener future, when we would like to have at the same time reduced energy costs in the data center, then here we go. This is a big part of the operational expenditure. And using a graph from Uptime Institute, a similar one which we have seen. I would like to point out, same thing like Jay, that the most concerning stuff for sustainability purposes is the power consumption of the data center. And the second one is PUE, power usage efficiency. It's a KPI, which reflects almost to the same thing. And then we go down to the other things. And as Jay mentioned, same thing. Carbon emission is not yet so high in consideration. But what we want to do from Harting is to optimize the power consumption, definitely. Then we go into the world of connectors. What you can see on the picture on the left side is a C connector. It's a power connector, or plug actually, which we can see a lot in data centers, or we saw a lot of them in data centers. And then we have on the right side our Harting connector. We have several, definitely a lot of connectors, but this is one type which we wanted to show and which we use in the data center environment. Then what we did is actually we took the old and the new, to simply say, and we tested in a laboratory. How are they performing in a way of using power. So once you have a device where power is flowing through, you will have resistance in that one, also in the connectors, of course, and then you lose power. So our idea is that let's have such kind of devices and equipment in the data center which are optimized to lose less power, because a lot of main systems like cooling, like optimized servers and so on are already optimized, to be honest. So taking, for example, the PUE, the power usage efficiency, it's not really impacted in the recent times. So it means we cannot really optimize further on the big ones. We can optimize the smaller parts of the system, which are still critical, like these kind of connectors. What we did is that, so we measured the energy losses, and to be honest, very surprisingly even, we saw that our connector is losing almost 50% less energy than the one which is used very commonly in this industry. So it's a very interesting finding, and based on this, of course, it's a very good thing for our customers also to understand this one. But what we did also is we made a scenario, and I was talking about the hyperscales. We took like a 15,000 rack data center, and then we took a look what happens when you use new and more energy efficient products. In this case, comparing the CE connector with our HAN Eco connector. So, of course, the upfront cost, so this is about the CAPEX, which I was talking about, is a little bit higher because the technology is much more advanced, and the know-how is much higher behind. But afterwards, when we calculated with the energy prices in Europe, actually this one, then we figured out that at the end of the day, we are leading to, as I mentioned, 50% saving in energy loss. So this means in this condition, in a year, about 760,000 kilowatt hours. And that got us to over 95,000 euro saving. It means this is a lot of money, in my opinion, to be saved just for using a much high-end connectivity, just to plug in the power into a couple of applications. So we are very glad that we got these results, and we can also share with you. I was framing a little bit about how this connectivity saving is happening with using our solutions, and I would like to bring up this slide. If you have a mood, we made a white paper which is actually showing also the calculation and a lot of other aspects. But of course, I don't have time for that today. But just click with your phone and you can download the white paper if you are more further on interested in the topic. I would like to go into the online faster and the maximizing of IT space part of my presentation. So here is again an approach what we find very important for our customers. So in this overview, you can follow actually from the left side, from the grid side to the right side, how the power flows through the data center infrastructure. And here it's very clear that we can also, when we build up a data center, we actually have this facility and the supplier, so the IT side of the building. It's important because once the uptime, so how fast we can um, set up the whole infrastructure, is coming into scope, then it's very important that how the facility and the system supplier side is coming together. And you can see with some red marks and some small yellow connector shapes, how important is that using connectors into connecting these two sides, because it saves a lot of time. It saves a lot of actually saves us from using a lot of um, highly qualified workforce. And it's, of course, as I mentioned, it has a lot of to do with power consumption and reliable power to the servers, to the IT side. Coming into some real examples, one of the projects which I'm happy to share with you, it's running since a while, is the power distribution, so the PDUs, power distribution units, and their connectorization with cables from Microsoft. So here what you can see is how the power is coming from the distribution line, overhead power distribution line, down to the servers. And in this way, it helped a lot Microsoft, because it was hardwired most of the time before, or some connectors were used which are not which were not standardized by them. So it was a lot of complicated of purchasing. It was a lot of complication in worldwide supply chain. So what we helped them with was to make a universal PDU, which they use, and also be universal in a way how to connect these to the power infrastructure. And that means if you are planning a data center any part of the world, you can use the same connectivity, and you can use, of course, our company to serve you anywhere there, because we are also global. And then this one was reducing the lead time also by 75%, which is a huge reduction. But at the end of the day, as I mentioned, the most important is to have a standardized solution which gives you the opportunity to use it all over the place, and to separate these two sides of the data center, not to have hard wiring, not to have complicated work on the site. Everything can be plug and play. So this is very important. Another one, as an example of applications, is also close to the first one, which I just shown. It's again using the power, bringing them down to the servers. But this solution is also connectorized at the moment from our approach. And then you can have this kind of type of boxes under the bus systems in the server rooms. And these can be, as I mentioned, also connectorized. The good thing with this one is everything is pre-tested. In our facility, we are guaranteeing you that, or our customers, that it works on the site, it's plug and play. And then we can also help a lot with our customized solutions to go into the direction of, okay, you need a connector, but then of course you need a cable. And then you can also see in this picture, you need a small box which actually receives the power from the bus bars. So why not we are giving you the whole solution, and we are taking care of that with our own production. And it is very popular, to be honest, in our field of operation. It grows much more than other parts. So just a little bit repeating, we have the flexibility, of course, the workforce doesn't have to be qualified. And this is one of the problems which I also read a lot from the press, that having the right workforce for the data centers is not so easy. Just summarizing a little bit about these two kind of connectivity, which I was just showing you. So saving power through this one, which I started the presentation with, and then also the CE plugs are, which you see the red one, are not flexible, because you can see, which I haven't mentioned yet, that in our connector we have modules. So it means you can have the different modules with different power ratings, or you can even have power signal data in one connector with using a modular system. So this is definitely, of course, an advantage, which I would probably point out, is that you can also switch the side of the male and the female. It's a little bit more technical, but it's very useful with the CE plug. You cannot do that. And we can also provide the housing of a connector, so the outer shelf to be more customized in some cases. Sometimes it needs to be longer for more cables and so on. But you can also, you had a chance to read on the screen about the benefits. The other project which I wanted to show is the Open Rack project. So this comes from OCP, Open Compute Project Foundation. This is pretty well known in the infrastructure side of the data centers. So this is an organization which promotes actually kind of standards to be followed. So what you can do is, as a supplier for data centers, you can participate in this project, and then with a lot of other players and companies, and then you can propose together in different groups, for example, an infrastructure which is optimized, which is having the know-how from many sides, and then it's going to be an OCP standard later on. And if you're running your data center on an OCP standard, it means you can use free, as in the world of softwares before, everything for free in a design, which is, I think, very beneficial at the end of the day. So for this one, we have also developed our solution for coming down again from the power to the servers. We really reduced the size, and you can see from a little bit blinking in from the left side this connector, and it has a lot to do with which I mentioned also, to have more power in a smaller space is a huge benefit today. Especially mentioning already here probably the AI, which makes our servers really power hungry. Several times more power is needed for the AI. So I think it's also for the data center market and the players and the people who are following it, this will be a little bit scratching the head. Also, for example, for you using new technologies or renewable energies, because power will be much more needed. So it gets our work even harder. Yeah, and then one more example from our company is that plug and play solutions are also used in different other areas, not just in the power critical infrastructure, but for example in lighting. Here we are also reducing the footprint, reducing uptime. Actually, the same kind of benefits, but you can see that this kind of tiny smart connector helps a lot. And definitely on site, you can imagine the hyperscale data centers are huge, so you can save a lot of time and money. Coming back to the objectives once again, is that to get online faster, the industry needs this actually, because the demand is growing from the usage of data, maximize IT space to have smaller space with more power, and have more space for the IT, and then be energy efficient to use smart solutions which are reducing your cost of energy every year with a sustainable amount, which will actually help the customers in this case. So I would like to thank you so much for listening to my presentation. You can see the slide with my contact, and if you need further, you can also grab the QR code.
Thank you so much, Andras. Thank you so much. We haven't got much time. We're about to move on to the next session, but just quickly, a couple of questions that I'd like to put to you. What's the highest ampere for your connectors? What can they carry?
Yeah, thank you so much. I think this is an important, because as I mentioned, higher power is needed. Our connectors can do 200 amps, which is great, because usually recently it's still around 70 and 100 amps, which is needed in a server.
Thank you. And just sorry, just quickly.
No issues.
Are your products UL certified, and what's the importance of that?
Yeah, UL certification is very important, especially for our international customers, so the big ones who have their data centers all over the world. And of course, without saying too many names, they are coming basically from the US. So this is a certification for the US, but this is what we see is getting more and more important globally, and we have for all our products and cables the UL certificate.
And I suppose that's going to play a more important role, as we heard previously. We're going to have to start reporting on more, giving more
definitely
concrete facts and figures. So do you think sort of this plug and play nature is going to play a big part in the next stage, where we're going to have to be reporting on energy efficiency and sustainability?
Yes, of course. I didn't mention in my presentation, but what we are already working on is, for example, a kind of a connector where you can already measure the power, which is running through.
Which is which is going to play a huge part in that.
So this is going to be a data which you can collect, and you have the real-time data, for example.
And you've got the data right there.
Yeah.
Okay, thank you so much for that, Andras. Sorry to move things along. We're just trying to
No
schedule.
problem.
But again, thank you for joining us today, and have a great rest of your day.